Okay, so today we did a little experiment with inertia. We took an index card, we put a mass on it, we had you move the index card around the table and describe the motion of the mass relative to the index card and the motion of the mass relative to the desk. So as I am moving the mass with the index card, the mass is not moving relative to the index card, but if I stick my hand back here, you notice that the mass is moving relative to the desk. So we brought this idea of appropriate frame of reference back. Okay, then the next thing we asked you to do is sort of check it out with putting more masses on, and we only use 2 in class. And by the way, you can do this at home with any piece of paper and some coins or candy. And we did the same thing, we moved it around, but we tried to see if, when I had more mass on this, if it was a little more difficult to get it moving. And indeed, you should feel a little more friction, static friction, when there's more mass, more gravitational force down, more surface area in contact, larger the static friction force. So then the next thing we did is we had a single mass put on our index card, and we pulled the index card straight out. And what you tried to see is the motion of the mass relative to the card, and which means the card is moving, in this case, towards me. So the mass looks like it's moving away from the index card, from that frame of reference. And then relative to the desk. So relative to the desk, the mass did not move. I'll try to see if I can do that one more time. I've lined my finger up with where the mass is, and there you go. That one moved a little bit, but pretty close. And then we had you do that with more masses, and you should notice that you just have to pull it a little more quickly in order for it to work. Last but not least, we did sort of a little magic trick. We took a cup, we lined up the mass with the opening of the cup, and then we pulled the index card out. And it should go straight down. Now, if you're not pulling it straight and or it's not lined up or you're pulling it too slowly, you will get the cup to tip over. So that's something. It has to be perfectly lined up with the opening. And the idea with this is that the mass has inertia, a resistance to a change in its motion. So as long as we pull the index card quickly enough that static friction does not have a chance to drag the mass with it, then as soon as the support force from the index card is gone, the mass will drop straight down. The gravitational force is pulling it down. There's nothing supporting it anymore, so it'll go straight down in the position that it was in. All right, great.